So vectors part 2. And I'm going to use the same vectors from earlier. A, B, and C. And I want to show you how we use the components of each vector to find the resultant. And what I mean by a component is one of two vectors, so this would be one, and this is the second one, that are perpendicular to each other. So perpendicular to each other that will add up to give us the same vector. So I'm going to call this one A sub x and A sub y. We will call this angle theta. And you'll notice since we have perpendicular vectors, we can use trig to determine what these are. So for this adjacent side, we have the adjacent side that we're looking for. We have the hypotenuse. And the ratio between those two sides will be equal to cosine theta. So this adjacent side that we're looking for should be h times the cosine of theta. We get A sub x is A cosine theta. And if you look at this vertical piece, let me do this in a different color. It's opposite of the angle. So we have the opposite side, we have the hypotenuse, or we're looking for the opposite side, we have the hypotenuse. The ratio between those two sides will be sine of the angle. So the opposite side will be the hypotenuse times the sine of theta. So we get A sub y is equal to A sine theta. By taking a vector and breaking it into these two components, what we're doing is called, depending on who you ask, decomposing or resolving a vector. So first thing you do is resolve anything at a weird angle. The next thing we're going to do is add all the x's together and add all the y's. So if you'll notice, B doesn't really have a horizontal component if it's perfectly straight up. C doesn't have a vertical component since it's horizontal. So if we add all these components together, it would look something like this. A sub x, A sub y, then B only exists in the y, C only exists in the x, and we can substitute this in for A cosine theta, and we can substitute over here A sine theta. So we get that x. So the sum of all the x's is going to be A cosine theta plus c, and the sum of all the y's will be A sine theta plus b. Keep in mind c goes against A, so we're actually adding a negative. The next step is draw a new triangle. So we'll add A and C together. Let's say I drew this properly. and C is, or A sub x is just a little bit longer than C. I get my resultant x. And you'll notice that A and B are in the same direction. So adding those two together, I might get something like this. Let me change the color. And so maybe this is my new resultant. Where this is A sine theta plus B. And this is A cosine theta. We could say plus C, but remember it's a negative. So we could maybe write this as A cosine theta minus the magnitude of C. And so this would be our new resultant. And theta, if we're looking for, well, that wouldn't be theta. It's not the same angle as this one over here. So let's call it alpha. If we have these two sides, then that's the opposite side, and the adjacent side we can use tangent. Tangent alpha should be the opposite over the adjacent. If I want to get rid of the tangent, I need to take the inverse of that function on both sides. Don't know what happened there. We'll get inverse tangent of the opposite side over the adjacent, where the opposite side is the sum of the y's, and the adjacent side is the sum of the x's. And we would report our answer as r at some angle theta. Don't forget your units, degrees, radians, whatever it is. And that's how you use component method.